too far with a mistake that could cost, you know what I mean? It's like one of those problems where you could lose a lot of valuable time if there's something fundamentally wrong with what people are doing. And I don't know, because I didn't walk around and hear and see everything. But I did hear the word symmetry, because you guys know that an annular region, right? You have a circle, and then you have another circle, right? What are the radii of these circles?
1 and square root of 5.
Okay, so maybe that's my square root of 5 is a little more than 2, so maybe 1 is like in here, right? Okay, now my question is, what's the function that I'm integrating? So f of x comma y is x squared plus y. And let me just pick a point that might be in that region, like, is 2 comma 2 in that region? It sure is, right? 2 comma 2 happens to be right here. And I noticed that f of 2 is 4 plus 2 is 6. So guys, I can't really draw this, but I can tell you that that green represents being 6 above the paper, okay? But I also noticed that another point is on the paper, namely down here I have, that would be what, 2, negative 2, right? So what is f of 2, negative 2?
2.
It ain't 6, right? So I think what I'm saying is, yeah, I like to use symmetry whenever possible, but because of the nature of my function, if I think that integrating here is going to give me the same value as integrating there, then I'm missing the concept of whether the z value is above or below the paper. Well, I guess this one is still above the paper, but not as much, right? Does that make any sense to you guys? So I guess I would caution you on using symmetry for this problem, but I'll let you get back to work. Yeah, I just wanted to give, hint number 2. I just heard Sullivan talking about it to his group, but yes, your limits of integration. We know that dA, hey guys, it says polar coordinates, right? We know that dA can be represented as r dr d theta. R dr d theta, right, me pirates? And then, do you guys understand why I want to integrate from 0 to 2 pi when I'm thinking of theta? I kind of explained that with the other little hint, is that some of us wanted to chop it up and just go from 0 to pi or 0 to pi over 2, but we could run into problems there because I'm integrating this function. Now this, we have 1 to square root of 5. See, what am I writing? When I write that 1 and square root of 5, what I really mean here, these are functions of what? Well, it's like r is a function of theta, right? I mean, in general, the way this is going to pan out is you'll have theta equals 0 to theta equals 2 pi, but the inner integral is going to be r is f1 of theta to r is f2 of theta, right? Now, you know what's wrong still, guys, with my expression is this. This is no good. You can't put x's and y's in there. We have to change them, right? But what do we know that y equals? R times the sine of theta. And how about x squared? I guess that would be r squared cosine squared theta, right? And what I'm starting to say is, I mean, depending on your personality, I guess, you may want to distribute that r through. You may want to write it as 2 integrals. I don't think that's necessary here, but you know, there's a lot of stuff that happens. That extra r, right, is going to have to come through. Again, why are these numbers 1 and square root of 5 instead of functions? Well, it's only because the region that I picked was really nice, right? Matter of fact, we have a conversion between x's and y's besides the r cosine and r sine, and that's that x squared plus y squared is always equal to what? R squared. So if r squared equals 5, for instance, then r is plus or minus the square root of 5. And that's where I said I can make that upper limit the square root of 5, and I can make the lower limit 1. I think the problem would also work if I used negative 1 and negative square root of 5. Oh, I'm not going to do that. Anyways, maybe that's enough hinting that you guys can take it from here. I think so. We'll let you work. We'll add it to posterity. This cosine squared theta, we know, is equal to 1 plus the cosine of 2 theta over 2. And that may be helpful also.
Six pi, would you say it comes out?
I'm quietly working on this one while they finish up.
Isn't 6 pi? Oh, you're still doing it.
I'm working right now.
What?
In front of our very eyes.
Oh, you did your power reducing at the beginning. It is easier to integrate with respect to R first, and then do your power reducing. I mean, I'm just thinking it gives you less fractions.
You might be right.
I like fractions. I'm not a big fan of fractions or subtraction.
R to the 4th cosine 2 theta. 1/3 R cubed sine theta. And we're going from 1 to the square root of 5. Wow, this does get bad. 0 to 2 pi. So let's see. I get, well, if I plug in that. Oh, cool, I get 25. So I get 25/8, and then let me just plug in the 1, minus 1/8. And then here I get plus 25/8 cosine of 2 theta, minus 1/8 cosine 2 theta,
Did power reducing before you integrated?
and then plus
Huh?
Did you guys finish up there?
I'm answering. 6 pi, it feels a little too nice.
Yeah.
It's not 6 pi?
I'm still figuring it out.
I don't want it to be
You don't
that,
want it to be that. It's like when you learn to reduce rational expressions and it comes out to be 1 and you're like, really? All that garbage equals 1. It's kind of fun if it comes out nice.
I guess that is
It's
a
kind of fun, but then you spend the next 10 minutes questioning whether you're right.
Right. But would we question it less if the answer came out nasty? No.
Yeah.
I wonder.
If it was from the book, I would question it if it came out super nasty. Because generally the book doesn't come out nasty. On exam, I don't question it because
Anything.
I don't.
'Cause
you don't trust me.
Yeah, well.
There's no trust whatsoever.
more likely it
Okay.
doesn't come out pretty, so.
Plus, and then I'm getting 1 minus 5 radical 5 over 3 cosine theta from 0 to 2 pi. That's a 2 pi. Hey, wait a minute. Hey, wait a minute. Are my limits of integration 0 and 2 pi?
I thought that were.
Well, wait a minute. Isn't it true that the cosine of 0 is the same as the cosine of 2 pi?
Yeah.
And isn't it true that the sine of 0 is the
Yeah.
same as the sine of 4 pi? So isn't it true that none of that's going to matter? Because I'll be subtracting it off.
Good, that means that when I integrated that wrong.
6 pi minus 0 is 6 pi. Yep, Matthew?
This looks a little easier.
Wait,
You had a question.
I'm not sure.
But
Let's see.